Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on trigonometry, and in particular we're going to be talking about simplifying trigonometric identities. So if you find this video helpful, smash the like button, consider subscribing, and let's go. So simplifying and then the more complicated proving trig identities is probably the bane of most pre-calculus students' existence. Now I will put this disclaimer now. If you're looking for a magic answer that's going to always let you solve it, unfortunately this video is not for you, and you're not going to find a video. There's no one-size-fits-all method that you can memorize to solve or simplify any trig identity. That being said, there are some tips and tricks you can use and know well that will help you along the process. Because as you do more of these types of problems, you'll get better intuition, and that's where you really improve at these. So, my key tips are going to be, you always want to look for places to use the reciprocal, quotient, and Pythagorean identities. So that's the identities I have here on the first page. And in particular, the ones that are going to be most useful for you is anything that's going to let you rewrite functions in terms of sine and cosine. So maybe the secant and the cosecant reciprocal identities. These quotient identities, because my third tip is, when in doubt, write everything in terms of sine and cosine. It's going to be a lifesaver at times. The other type of identities you really want to know are the Pythagorean identities down here. And I will be making another video in the near future justifying where these identities come from. Now, the third thing is, whenever you're doing these problems, you're going to need to utilize your algebra skills. And that might mean combining fractions, factoring, or in some cases, multiplying by 1 in a fancy way that I have there in quotes. So multiplying by something by 2 divided by 2, that's the same thing as 1, just written in a fancy way, 2 over 2. So let's see some of these in action. So the first example that I have here is where I want to simplify this expression. You should look at it and say, okay, the obvious thing staring me in the face is I have these two factors. And this is where using algebra skills can help. What you might try to do is FOIL these out, multiply those factors in the numerator. So this first step was an example of where we're using some algebra skills. Once we're at this step, you might say, okay, I have a cosine here, which I might try to rewrite using some identities, or I have a cosecant squared minus 1. Both these, if you are too lost, you can always try writing these in terms of sine and cosine. But one thing you want to get good at is not just using the Pythagorean identities as you'll typically see them written, but be able to use them rearranged. If you notice, if I subtract a 1 from both sides in my Pythagorean identity, 1 plus cotangent squared is equal to cosecant squared theta, then that gives me cosecant squared theta minus 1 is equal to cotangent squared theta. And cosecant squared theta minus 1 is my numerator right now. So this is a prime example of how we apply Pythagorean identities to simplify expressions. So if we go back down to our equation, we would simplify it with that. So we get now cotangent squared theta divided by cosine squared theta. This is a good point where you would say, well, there's no algebra. Any Pythagorean identity I would use would either expand the numerator or denominator. So I'm going to go with my trusted and true trick, write everything in terms of sine and cosine. So I can take that cotangent squared theta and apply my quotient identity to write it as cosine squared theta divided by sine squared theta. And from here, you would then look at this and probably say, I don't like fractions and fractions. That makes me feel uncomfortable. And if it makes me feel uncomfortable, it hopefully makes you feel uncomfortable. So we can get rid of the fraction by recognizing that this is the same thing So we have that we just multiply the top numerator and denominator of our fraction by sine squared of theta. So this is really multiplying by 1 in a fancy way because it lets us get rid of that fraction in a fraction. And our cosine squares will cancel to leave us with a 1 over sine squared of theta. But again, by one of our reciprocal identities, this is the same thing as cosecant squared of theta. And now you've simplified this expression about as much as you're going to possibly be able to get it down. Cosecant squared of theta looks pretty nice to me. So, and this is just a slow application of each of these different tips I had. The algebra, the Pythagorean identities, the quotient identities, the reciprocal identities, and multiplying by 1 in a fancy way. Hey, so I hope this video was helpful, and if so, hit the like button and have an awesome day.